In this video, we are going to talk about factoring trinomials of the form ax squared plus bx plus c, where a is equal to 1 or a equals -1, then also solving the quadratic equations of the form ax squared plus bx plus c equal to 0. So recall that factoring is opposite of multiplication. We must work backwards. We have multiplied x minus 6 and x plus 3 in the past to get to x squared minus 3x minus 18. Now we're going to be going from from a polynomial to a factored form. So we will be working backwards, breaking a polynomial into the factors that were multiplied to get to that polynomial. So quadratic means second degree, so there's x squared in these. And if you see on the factored form, x times x, when you multiply first, outer, inner, last, FOIL, when you multiply, you will get, because first times first is x squared plus 3x minus 6x minus 18, first, outer, inner, last. So that will add up to, combining the like terms, will leave me with x squared minus 3x minus 18. So quadratic trinomial is a second degree. Second degree trinomial means there's three terms. So second degree in three terms, ax squared plus bx plus c. Okay. Our focus today is to deal with the ones that have a as +1 or -1. So difference between quadratic trinomial and quadratic equations is quadratic trinomial would be, for example, x squared minus 3x minus 18, and we might be asked to factor it. Factor means break it into pieces, okay? Write down this polynomial as a product, okay? Quadratic equation, when you see the word equation, that means we have an equal sign in there, and there's one extra step. There's usually it's equal to 0, but it can be equal to any other number as well. Okay, so there's an equation. Equation means there's an equal sign, and then in that case, we would be asked to solve. Solve means find the values of x that will make the left side and the right side equal to each other. Okay, so keep in mind two kinds of problems you will see in the homework. One kind will be factor the trinomial, and the second kind would be solve the equation. So if there's an equal sign, it's an equation, there's one further step. You have to use zero product property after you factor. Okay, so let's look at, there's many possible ways to factor these, and I will show you one today called the X method to factor these trinomials. Very first step is to factor out the GCF, then use the X method for remaining trinomial. So if there is a GCF, you must pull that out first, okay? If there's a GCF, pull it out. If there's no GCF, proceed with the X method. Keep in mind, we're always going to be comparing it with our standard form of quadratic equation, which is ax squared plus bx plus c equal to 0. Okay, so we're going to compare it with ax squared plus bx plus c. All right, so first of all, is there a GCF in example number 1? Looks like there's no GCF. So that means proceed to the next step, which is I'm going to make an x. And I'm going to show you a little bit longer way, the actual way, so that you understand why does the shortcut work. But I'm going to give you shortcut also in a minute. So a in this case is 1. A times c goes here, b goes here. 1 times 6 is 6, b is 5. So think about two numbers that multiply to give you +6. 1 times 6 is +6. And they add up to give you 5. They are 2 and 3. So what we're going to do is we're going to break the middle term, which is 5x, into these two new, using these two numbers that we just found. So I'm going to write everything else as it is, x squared plus, instead of writing 5x, I'm going to write 2x plus 3x plus 6. Instead of 5x, I'm writing 2x plus 6, 3x plus 6. Okay, now we are going to be factoring by grouping here. That means we are going to look for if there's any common factor between the first two terms or the last two terms. Can we pull out an x from the first two terms? So that is going to leave me x plus 2. And from the next two terms, I can pull out a 3. The greatest common factor is 3, so that will be x plus 2. So you can see these two parentheses are same. That means you did it correctly. So we factor by grouping when we have 4 terms, x squared plus 2x plus 3x plus 6. Okay, so there's a common factor x plus 2 in here. I'm going to pull that out all the way in the front. That's my GCF, and I'm left with x plus 3 in here. So x plus 2 times x plus 3 is my solution. That's the factored form for this polynomial. And you can check your work if you want. You can do the foiling first, outer, inner, last. X times x is x squared. X times positive 3 is positive 3x. Inner times inner is 2x. Last times last is 6, which is x squared plus 5x plus 6. And that is what we started with. Okay, let's look at the next one, and then we'll move on to the shortcut. Okay, again, is it in GCF? Looks like no. What is A here? What is B? What is C? A is positive 1, B is negative 1, C is negative 30. Remember, we are comparing to this equation. The A is positive 1, B is negative 1, C is negative 30. So draw your X. A times C goes on the top, B goes on the bottom. Negative 30 goes on the top, negative 1 here. Think of two numbers. They multiply to give you negative 30, and they add up to give you negative 1. What are the two numbers? Well, they're going to be 6 and 5. Which one should I make negative? I'll make 6 negative because I want them to add up to negative 1. So negative 6 and 5. So now we're going to leave everything as it is, but break this middle term using these two new factors, because negative 6x plus 5x will be equal to negative 1x. So we're not really changing anything. Minus 6x plus 5x minus 30. And you could switch. You could write 5x first and minus 6x later. That's totally fine, okay? It's totally okay. Now, when we have 4 terms, we're going to be factoring by grouping. Okay, factoring by grouping. Is there any common factor between the first two terms? Looks like there's an x, so x comes out. X minus 6 goes in there. And from the next two, looks like the GCF is 5. X minus 6 is in there. You will see when you have same thing in these two parentheses, that means you are on the right track. You got this factored correctly. If these two parentheses do not match with each other, that means either your polynomial is prime or you have messed up somewhere. Like, look at your work again. Now, x minus 6 is a common factor. I'm going to pull it out all the way to the front, and then we are left with x plus 5 inside. So x plus 5 is left inside. We pulled out x minus 6. This is the factored form. Now let's talk about the shortcut. What is the shortcut? So whenever your a is equal to 1, the shortcut only works when a is equal to 1. Keep in mind, that means your first term is positive 1. In that case, you can kind of, skip the middle step and just say, okay, so your two factors were 2 and 3. That's what you're going to write in your two parentheses, x plus 2 and x plus 3. Here, your two factors were negative 6 and 5. You're going to write x minus 6, x plus 5 as two product of x minus 6 and x plus 5. That would be your factored form. So let's try to use the shortcut in the next one. Not an equation, expression, quadratic trinomial. We are trying to factor it. So think about a, b, and c. Your a is 1, b is 4, c is negative 32. Okay, so a times c goes on the top, negative 32 goes here, b goes on the bottom, which is 4. Two numbers that multiply to give you negative 32 and add up to give you 4 are going to be 8 and 4. Which one should I make negative? Well, we should make 4 negative, because this way they will multiply to give you negative 32, but they'll add to give you positive 4. Now I'm going to use a shortcut. So this is x squared. I'm just going to say x, because when I multiply them, I'll get my x squared back, and then plus 8 and minus 4, plus 8 and minus 4. X plus 8, x minus 4. So 3x squared plus 9x minus 30. Is there anything I can pull out from the parentheses here? So we have 3. 3 is the GCF in example number 4. I can pull it out, and I am left with x squared plus 3x minus 10 inside x squared plus 3x minus 10. Good. So the outside 3 in the front is just going to be sticking over there. Now I'm just dealing with the inside of this trinomial. So think about A and C here. A is 1, B is 3, C is negative 10. A times C goes on the top, B goes on the bottom, negative 10 goes on the top, 3 goes here. So two numbers that will multiply to give you negative 10 and add up to give you positive 3 are 5 and negative 2. 5 times negative 2. 5 times negative 2 is negative 10, and 5 minus 2 is 3. So now I'm going to write two parentheses. Again, we can skip the middle step only when A is equal to 1. Your first term is 1. That's when you can skip the middle step, which I showed you in the first two problems. All right, so it's going to be x plus 5, x minus 2. Again, the order doesn't matter. You could write x minus 2 times x plus 5. And this is our factored form. Do not forget the 3. The 3 has to be there because when you multiply these, you have to get back to the original polynomial you started with. Let's look at example number 5. This one is a bit different because when you factor, you want to be able to get a y to the fourth. And so think about, you can think about a clever substitution, or you can still use a trick over here. A times C is negative 70, B is negative 3. 10 and 7 are your numbers. We'll make the 10 negative because we want them to add up to negative 3. Now, when you write my two parentheses, earlier I used to put an x and an x because I wanted to get x squared back. But now I want to get y to the fourth back, so I'm going to say y squared and y squared. Y squared minus 10, y squared plus 7, and that's it. That's my factored form of this polynomial. You can go ahead and multiply these two and check back and make sure that you got the correct answer. Okay, solve each equation, factor, and then use the zero product property. So here now we're going to be solving the equations. Keep in mind each of these have an equal sign. That means we're looking for the values of x that will make our equation true. Both left and right hand side will be equal to each other. So our goal is to first bring everything to left hand side, factor, and then plug each factor equal to 0 using the zero product property. So let's first think about x squared plus 5x plus 6. We just did it a minute ago. Two numbers that multiply to 6 add up to 5 are 3 and 2. So when I factor x plus 3, x plus 2 equal to 0. So zero product property says when product of two binomials is 0, one of them must be 0. So either x plus 3 is 0 or x plus 2 is 0. So this leaves me with x equals negative 3 or x equals negative 2. Second example, we are looking for two numbers. They multiply to give you negative 30. They add up to give you negative 1 and negative 6 and 5. So x minus 6, x plus 5 equal to 0. Again, we got to go one step further. It's an equation. It's not an expression. So we're not just factoring. We're solving these equations. That's why you see the word solve here, solving these equations. So now we can use the zero product property because product of two binomials is 0. One of them must be 0, x plus 5 equal to 0. So here I get x equals 6. From the other one, I get x equals negative 5. So these are my two possible values of x that will make my left and right hand side equal. Number 3, again, from the last, looks like 3 and 4 I wrote again, so I'll get rid of the third. Is there any GCF in number 3? Looks like yes, there is a GCF. 3 is a GCF. X squared plus 3x minus 10 equal to 0. Now we can go ahead and divide both sides with 3. That's a nice thing when you pull out the GCF because it is going to make your left hand side easier, but the right hand side, 0 divided by any number is just 0. 0 divided by any number is just 0. Now let's go ahead and factor two numbers that multiply to give you 10, add up to give you 3 are 5 and negative 2. So x plus 5, x minus 2 equal to 0. So we're left with 2 and negative 5. These are the two possible values of x that will make my equation left-hand side equal to right-hand side. Look at number 5. This one looks a little bit odd because I don't have a 0 on the other side and my equation is not written in the standard form. Keep in mind, we first need to write our equation in the standard form, which is ax squared plus bx plus c equal to 0. So let's go ahead and write it in the standard form first. So I'm going to bring everything to left-hand side. Minus 45 equal to 0. This is a 4. Two numbers that multiply to give you negative 45, add up to give you positive 4 are 9 and 5. We will make the 5 negative because we want them to add up to positive 4. So we're left with m plus 9, m minus 5 equal to 0. So my two answers are either m equals 9 or m equals, let's go ahead and use the zero product property. I rushed and that was not okay. So I'm going to get the two answers. Either m is negative 9 or positive 5. Okay, let's look at number 6. A squared equals 4a. How do I deal with a squared equals 4a? I don't have a 0 on the right hand side. And I'm going to bring everything to left hand side. If you compare it to your standard form, ax squared plus bx plus c equals 0, your a in this case is 1, b is negative 4, and c is 0. Okay, you can use your x method here as well, or you can just pull out the GCF. I see I can get the GCF out, which is a, and now my equation is in the factored form, and we can say either a is 0 or a is 4. These are my two answers. Okay, if you would have used the x method, you're looking for two numbers. They multiply to give you 0 and they add up to give you negative 4. What would be those two numbers? They multiply to give you 0 and they add up to give you negative 4. Those two numbers will be 0 and negative 4. Right? They will multiply to give you 0, add up to give you 4. So you could have used alternate technique, which is a minus 0 and a minus 4 equal to 0. You could have used that as well if you didn't want to use the GCF technique. Let's check out our next problem, factoring the trinomials. Now, we're dealing with the trinomials that have a as negative 1. So your first term, you do have a negative in the front. What we're going to do is we're going to pull out the negative, factor out a negative 1 from the whole trinomial. So if I pull out a negative 1 from this trinomial, I am left with x squared minus x minus 6. Because when I distribute the negative back in there, I will have this polynomial back. So that will make my life easier. I'm just going to be dealing with the inside trinomial now. My a inside, a is 1, b is negative 1, and c is negative 6. Two numbers that multiply to give you negative 6 and they add up to give you negative 1 and negative 2, negative 3 and positive 2. Negative 3 times 2 is negative 6 and negative 3 plus 2 is negative 1. So that should work. Now we can write it in the factored form, x minus 3, x plus 2. And that's our polynomial in the factored form. What if I had an equation instead? What if this was an equation? If this was an equation, I would have had negative x squared plus x plus 6 equal to 0. Then I would have solved. Directions would have said solve instead of factor. Instead of factor, directions would have said solve. So here the directions said factor, and in this one they would have said solve. So in that case, I would have to, same story, deal with the left-hand side and factor it completely. And we can go ahead and divide both sides with the negative 1. That will leave me with x minus 3, x plus 2 equal to 0, which is x equals 3 and negative 2. And these are my two possible answers. That will make the left and right side equal. Let's look at example number 2. Negative x squared plus 6x minus 8 equal to 0. So again, this one says solve, so I'm actually going to find the values of x. But before that, I'm going to make my life easy. Divide both sides with negative 1 since it's an equation. So that will leave me with x squared minus 6x plus 8 equal to 0, because 0 divided by negative 1 is still 0. Two numbers that multiply to give me positive 8 and add or subtract to give me negative 6 are negative 4 and negative 2. Now, when I use the zero product property, I can say either x is 4 or x is 2. Those are the two possible answers. One more example. Solution of a quadratic equation are x equals -2 and x equals 4. Write the original equation in standard form. So if the solutions are -2 and 4, if you recall, if x equals -2 is solution, then x plus 2 is the factor. If x equals 4 is a solution, then x minus 4 is the factor. So my polynomial would be x minus 4 times x plus 2 equal to 0. And we can FOIL it now. FOIL means it's okay to leave it at this point, but you can also go one step further. First, outer, inner, last. So x times x is x squared. Outer is 2x minus 4x minus 8 equal to 0, which is x squared minus 2x minus 8 equal to 0. And that is my quadratic equation that we started with.